Welcome back, Math 20-2. So far, we had dealt with adding and subtracting radicals, and we also did multiplying radicals. Now, back in elementary, when we learned numbers, first thing we learned was adding, then we learned subtracting, then we did multiplying. What came next? Division. So naturally, what's going to come next for what we're going to learn to do with radicals? Dividing radicals. This first part here is a nice little exercise for you to start off. So you may pause and do that, and then come back to the class example 1 where I am going to start. Okay? So the first one here, we found out from going on the top that multiplying and dividing are very similar, aren't they? So in this case here, this is the same thing as saying the square root of 70 divided by 7, which is the same thing as square root of 10. Okay? Next one here, well, we divide numbers and numbers. Just like when we multiply numbers by numbers, which is going to give me 3. 15 divided by 5 is 3. Then we divide radicand by radicand. So that's going to give me 18 divided by 3 is 6. There we go. Not that bad so far. Exact same thing as multiplication, except now we're dividing. Let's take a look at this one here. We have 20, number divided by number first. 20 divided by negative 4 is negative 5. Well, then we have to go radicand divided by radicand. Well, what is 40 divided by 5? 8. So that's going to be the square root of 8. Huh. But can this 8 be simplified? Yeah, it can. We learned that earlier. We could break that down. This is the same, 8 is the same as 2 to the power of 3. So there are 2 2's in 8. So we get negative 5 multiplied by 2 square root 2, which is negative 10 square root 2. Okay? Let's try this next one here. We have no coefficient, so we're just going to look at what's the radicand inside. I have xy and x, so square root xy divided by x. Well, here my x's cancel off. I'm just going to be left with square root y, because x divided by x is 1. And now here's our last. We have 10 divided by 20. That's the same as 1/2, or 2 on the bottom. Next, we have 24 divided by 2. So there's just a root, though this one on the top is going to be 12. Well, I could simplify this 12 is the same as 2 root 3 all over 2, which is the same as square root of 3. Wasn't that interesting? Because 2 divided by 2. 12 is 4 multiplied by 3, 2 and 2. So I have, take out a 2 in front. Okay? Here's the next one. It says, simplify the numerator and the denominator, then divide. So first here we're going to simplify the numerator, simplify the denominator, then divide. Because if I look at these numbers here, these are big numbers. Big numbers sometimes are very tricky to divide. Small numbers, a lot easier. So I'm going to first simplify 54. Okay? Let's take a look at 54 here. Oh, I'll just put it over here. So 54, and I'm going to break it down. Well, that's 9 multiplied by 6. This is 3. And 3 and 2. I have a pair of 3's that can be taken out. So let's go back here. The top part is 4 multiplied by 3, and what was left inside? We had a 6, square root 6. Now the bottom, 8, if I look at 8, that's the same thing as we have 2 and 4, 2 and 2. I have a pair of 2's. So 3, 2, and there's a 2 left over, multiplied by 2, square root 2, because there was a 2 left over. Now I'm going to continue this. What is this equal to? And I have 3, 4 times 3 is 12, all over 6, and we have root 6 over root 2. Now, what's 12 divided by 6? 2. What is 6 divided by 2? 3. We divide our coefficients, and then we divide our radicands. And there is my answer. So it wasn't that bad. We just had to break it down a bit and work with our stuff. So let's try example number 2. Those are big numbers, 126. I'm going to try break down 126 over here. Okay? So I break down 126. I know it could be divided by 2. Okay? So 2 is going to give me 63. Now I know this is 9 multiplied by 7. It's the same as 3 and 3. So I have a pair of 3's, and what's left? 14 inside. So that is 8 multiplied by 3, and there's 14 left on the inside. Let's do our bottom, 112. I know this can be divided by 2. And we're going to be left with 56. 56 is the same as, I could divide it by 2. I'm going to get 28. And that's 4 and 7. So we have 2 and 2. So I have a pair of 2's here and a pair of 2's there. That's 2 pairs of 2's. So that's 4, and what's left? Root 7. Now, dividing this, I'm going to get root 14 all over 4 root 7. So if I divide our coefficients, I'm going to be left with 6, and we divide those, root 2. That is my answer. Okay? Alright, so now let's try this next one here. It says, divide each denominator by the numerator and simplify. So if I'm looking at this, if I divide, it's like when we multiply, I must divide each of these by the root 5. So I'm going to divide first, because if I look at BEDMAS, division becomes for addition and subtraction. I'm going to first divide everything by root 5. So 20 divided by root 5 is root 4. 40 divided by root 5 is root 8. And then 90 divided by root 5 is equal to root 14. Oh, just wait. Root 18, sorry. Okay? So now, we're going to simplify these the best we can. This first one is 2 plus 8 is made up of 3 2's, so there's a pair of 2's we could take out, and another 2 left over. And 18 is 9 times 2, we could square root 9, which is 3, and there's a 2 left over. So I finish this, I'm going to be left with 2 minus root 2. Once we combine them, okay? I'll just show you again how I did the 18. 18 is 9 times 2, square root of 9, square root of 2, square root of 9 is 3, we're left with 3 root 2. Okay? Alright, so here is example 4. It says, complete the following and rationalize the denominator. So the way I like to think this is, we want to rationalize the denominator, meaning we cannot have a radical on the bottom. I like to think of it as thinking of sports teams and stuff like that. The team you're cheering for cannot be on the bottom. Same thing with radicals. You're not radical, you know the word radical, gnarly. You're not radical if you're on the bottom. You can only be radical on top. So we cannot have radicals on the bottom. They don't belong on the bottom, they belong on top. Because they want to be the best, okay? Same idea. So here we go. We have 1 over square root of 10. So they started it off, and they multiplied both sides by square root of 10. Notice how they multiply by the root, the top and the bottom? This is the same thing as multiplying by 1. So what do we end up doing is, we end up getting square root of 10 all over root 10 multiplied by root 10 is the same thing as 10. That's it. Let's try the next one here. Once again, we have this root 6 on the bottom, so they multiply everything by root 6 over root 6 to try and get rid of this root 6. So we're going to be left with, well, root 6 times 2, root 20 is root 120, because 6 times 2 is 12, and we have 0, 120, all over 2, root 6 times root 6 is just 6, 2 multiplied by 6, which is equal to root 120 all over 12. And this could be simplified even more. We could end up taking out a bunch of stuff there and simplifying it more, but we're just going to leave it at that now. Let's try the next one. So we can make that into a mix. Let's try the next one. Okay, so root 5 over root 5. Why? Because we have root 5 on the bottom. That's a radical. It's not radical to be on the bottom. It's only radical to be on top. If you're radical, you can only be on top. Alright, so here we go. We have root 18 multiplied by 5 which is the same thing as root 90. And then this is all over 5, all over 5. Because root 5 times root 5, that's the same thing as square root of 5 times 5. Which is 5. Easy. Alright, here's our next one. It wants us to express each as mixed radical, then rationalize. So sometimes it is easier actually to express it as a mix and then rationalize. So this here is the same as, if I look at 500, let's break it down. That's the same thing as 100 multiplied by 5. Wasn't this the same thing as 10 by 10? Hey, look, I have a pair. So we have the top 10 root 5. Now the bottom 27, I have 9 and 3. Well, 3 and 3. I have my pair of 3's. So I'm going to have on the bottom 3 root 3. Now, I still have a square root on the bottom. I have a radical on the bottom. It's not radical to be on the bottom. You're only radical if you're on top. So we must rationalize it. So I'm going to multiply by root 3 over root 3. Because really, if we're multiplying by root 3 over root 3, the same thing as multiplying by 1. So we're really not changing anything. It's like we're doing fractions. Okay, so now we're left with root 3 times root 3 is 3. So it's 3 multiplied by 3. And I have 10 root 3 multiplied by 5 is 15. Which is the same as 10 root 15 all over 9. Okay? That's it. Can't simplify anymore. Let's try the next one. 240 and 108. So I'm going to first do 240 on top. Okay? I know that's 10 and 24. This is going to be the same as 6 and 4, 2 and 2, 2 and 3, 2 and 5. I have a pair of 2's. So it's 3, and there's 2 multiplied by 2. And I have another pair of 2's multiplied by 2. And what's left? I have a 5 and a 3, so that's 15 for my radicals. 15's in the house. Okay? Now let's look at 108. Okay? Well, I know that is the same thing as 12 multiplied by 9. This is 3 and 3. This is 4 and 3. 2 and 2. So I have a pair of 2's and a pair of 3's. So that's 3 times 2 all over square root of 3. Well, this one here, we might not actually need to rationalize. Because if I divide this, these cancel off. So I'm left with 2 root 15 all over root 3. Well, can't root 15 be divided by root 3? Yes, it can. That's going to be the same thing as 2 root 5. And that's it. Or I could have done this. Or I could have gone 2 root. Or I could have gone 2 root 15 all over root 3. And I want to rationalize this because it's not radically on the bottom. I could have gone root 3 multiplied by root 3, which gives me 2 root 45 all over 3. But then I look at this root. This root 45 can be broken down to 9 multiplied by 5, which is square root of 9 is 3. So it's 2 times 3 root 5 all over 3. And these 3's cancel off, which gives us the same answer. I like this way a little bit better, but you could have also gone that way. They both would have got you the same answer. Okay, last question. It says, simplify the radical expression by rationalizing the denominator first. And the next one says, by dividing. So first we're going to rationalize the denominator first. So I'm going to get 2 root 50 minus root 14. And we want to rationalize. So that's root 2. Multiply everything by root 2 over root 2. Okay? Well, I'm going to get it all over 4 now. Oops, sorry, all over 2. And everything here on top must be multiplied. We have to use our distributive property like we learned in the multiplication class before. So this is going to be 2 root 100 minus root 28, which is equal to, well, square root of 100 is what? 10. So 2 times 10 is 20. Minus, well, square root of 28. If I look at 28, I have 4 and 7. I could take out a 2 there. So it's 2 root 7 all over 2. Well, now I could cancel these off, so that's going to give me 10 minus root 7. So that's one way. The other way is by dividing by the root 2. So let's try this one, by dividing each term by the denominator. So we're going to have 2 root 50 minus root 14 all over root 2. This one we can actually divide by this. If I had just a number there, if it was 3 on top, I cannot divide by root 2. There's no way to divide by root 2 because I need a radical to divide by radical, right? The radicands only affect the radicands. That's it. So I couldn't do that. But this one, I can. Or else, and both of these are divisible by 2, so I can divide by this root 2. It will work, which is great. So let's try this out. I'm going to get 2 root 25 minus root 7. Because 2 divided by 50 is 25, and 50 divided by 2 is 25, and 14 divided by 2 is 7. All right? Now, what are we left with? Root 25 is 5. 2 multiplied by 5 is subtract root 7, so we get 10 subtract root 7. That's everything. Well, I hope you understand this, and good luck as I see you tomorrow, and make sure you ask for some questions.